Let's take a look at the non-inverting amplifier. We're going to put two of the examples together, 7 and 8, and you can see the example on the page here. Negative feedback in a non-inverting configuration increases the input resistance and decreases the output resistance. The increase of input resistance and decrease in output resistance is close to ideal. We're going to see in this example, we're going to determine the input and output resistances for the amplifier shown. The op-amp data sheet gives Rn at 2 megohms, R out at 75 ohms, and the open loop gain at 200,000. The attenuation, defined as B of the feedback circuit, then is equal to that voltage divider, RF and RI. So RI divided by RI plus RF gives us 10K by 230K ohms, or a attenuation of 435 hundredths. Rn, then not inverting, is defined as 1 plus the open loop gain times B, all of that times the resistance in. So 1 plus 200,000, put a correct zero in there, and 0.0435 times 2 megohms gives us a resistance in, really big resistance in, 17.4 gig. And you never see gig as a value for resistance, but here you do. R out, non-inverting, then is the equal to R out divided by 1 plus the open loop times B, which gives us a value of 8.6 milliohms. So Rn non-inverting and R out non-inverting are close to ideal values. Now we're going to find the closed loop voltage gain. So in this case, negative feedback in a non-inverting configuration increases again the resistance and decreases the output resistance. So in this case, we are going to use the value from the previous step, 0.0435, as our attenuation. Okay, remember we solved it back here. So 1 over the closed loop gain non-inverting is the inverse of B, so 1 over B gives us a value of attenuation of gain closed loop of 23. In the last example, we're going to reconfigure the amplifier as a voltage follower amplifier. The voltage follower input resistance is greater for a given open loop and input resistor for the non-inverting configuration with the voltage divider feedback circuit. So we can see that here. Also, its output resistance is much smaller than B and is normally much less than 1 for a non-inverting configuration. We're going to use the same op-amp shown and configure it as a voltage follower. Determine the input and output resistances. So the input resistance then for the voltage follower, 1 plus the gain open loop times Rn gives us a value then of 4 gig ohms. R out then is equal to R out by 1 plus the open loop gain gives us 375 micro ohms. Notice that the input voltage follower is much greater than the input non-inverting. The output resistance for the voltage follower is much less than R out non-inverting from the previous example. So the voltage follower.